I don't. Is it possible?
Yes.
Yes, I totally agree it's possible. Here's why I ignore it. Here's why I ignore it. Hang tight. I want to show you something related to that. Not exactly that. I'm going to go to the 243 file real quick. I'm glad you brought that up. I ignore it, and here's why. It's in binomial. Yep, there we go. So, remember the discussion we had in class last week about sexed pullets, buying sexed pullets. I said it's a 90% chance you get a girl, a 10% chance you get a boy once they're sexed. And I use this all the time in class because it's pretty wonderful, even though Marge, who's laying eggs, is crowing like a rooster in our shed, which came up this morning and I heard, I'm like, dude, you're laying eggs. But what made me think of this when that happened, I was told that there's a small chance that a chicken is born with both male and female parts. And I said, really? So I Googled it. It turns out there's a 1 in 10,000 chance. So for every 10,000 flips of the chicken coin, one of them lands on its edge, which would be both genders. Now, I promptly ignored that when calculating buying chickens at a store, and here's why. Here's why. These are all the possible outcomes of roosters, chickens, and others if you buy 4 birds from the store, which if you put chickens in your house in Bend, you can buy, legally, you can buy a maximum of 4 within city limits on a 6,000 square foot or smaller lot. Okay? So if you buy 4 birds out of the store from, say, High Desert Ranch and Home, you might get 4 of those other cases and maybe 0 chickens and 0 roosters. You might get 3 of the others and 1 chicken. You might get 3 of the others and 1 rooster. See what's going on here? You might get 2 of the others, 2 chickens, 2 of the others, 1 chicken, 1 rooster, 2 of the others, 2 roosters. What I've done is I've listed out every possibility of what could possibly happen, including the edge flip. So in other words, this is including the edge flip of the coin. The edge flip would be very unlikely, like getting both genders. Then I calculated it by ignoring that third possibility and just looping it in. The difference between ignoring the others and including the others is a mere 0.0004, which is 0.04%. So it's a little bit wrong to not include them, but it's not big enough for us to worry about. And that's why I ignore the edge flip too. I mean, what would the probability of flipping a coin on its edge even be? I've seen it once in 20 plus years of teaching mathematics. So what do you want to call it? I shouldn't call it 1 in 20. That'd be an oversimplification, right? Because that would mean that we flip 1 coin every year and then mark it. How many coins get flipped in this class every term?
Oh my goodness.
Oh my goodness is right. So 1 times 3 times 20 oh my goodnesses. Is it worth worrying about? We can ignore it, right?
Yeah.
I love what you said, Josh. I love what you said.
It's just a possibility.
It is a possibility, but it's such a small possibility we can ignore it forever. And who did it happen to in here? Somebody in here, right? Yeah, somebody back here flipped it and went on its edge. You're all pointing at each other. It was her, it was him. Pam, I'm giving you credit. There we go. It doesn't matter because it happened once. It's a 1 in a million shot. It's a 1 in a million shot we can ignore it. So, another possibility. Heads, heads, tails, tails, heads, tails, tails, heads. That's it, isn't it?
Yeah.
That's it. We're done.
Is that the homework, like from last week?
It is. It's the project from last week. Exactly right. That helps you when things like coins and cards and real basic, equally likely events. That helps very much to help us. With the dice, it'll be helpful today too. Okay, now, what is the chance of getting both heads? 25%. Each of those outcomes is equally likely. That's your sample space. That's your classical sample space. Each one of those things is 25% likely. So therefore, it's 1 in 4 or 25%. Which is the same as both, yes, as both tails. Is also 25%. Now, explain to your neighbor. Explain that to your neighbor. What does it mean to have a 25% chance of getting both heads or both tails? Explain to your neighbor what that means. Because he's just flipped heads. He's just flipped heads once. This is back to our bet, right? He now thinks there's only a 25% chance he's going to get heads again. And you say, no, it's 50%. You guys were just telling me before. Every time I flip a coin, it's 50% heads, 50% tails. But then your neighbor goes, but I just flipped heads. That means it's only 25% I want to get heads again. That's what that top thing says, isn't it? What's the difference? What's he thinking of wrong on you?
Well, that, under all the head, where you listed it, that's the event space.
Yes.
The likelihood is the sample space.
Right.
And so there's different values.
What
So-
your neighbor has done is he's ignored the fact that, what is this experiment measuring? Flipping a coin, how many times? Twice. He's trying to break off the first flip and separate it from the second one. That's not what the 25% is measuring. The 25% says if you flip a coin 2 times, 1/4 of the time you're going to get heads, heads.
Okay.
1/4 of the time you're going to get tails, tails. Josh!
So are you saying that most of the time people commonly think of probability in a really fast, backwards way?
No, we think of probability in a non-random way. We're not good at being random. We think once something happens, something else needs that. I'm gonna prove it to you right now. No, I can't. How many of you guys taking me for 243 next term? That's too many. I can't do that experiment. I'm gonna use it in 243, and you'll remember it if I do it. No. Yeah. I can't create one right now.
You
off the top of
probably
my head
won't
either.
remember.
You will. You will. It's one of those episodic things people remember years later and
Oh.
come back and tell me.
Okay.
But anyway, it's not that people think of it backwards. It's that they create an order in randomness that can't possibly exist. Dude, let's do this right now. Let's simulate it right now. Grab your TIs if you have your TIs. We're gonna come back to this experiment. I wanna drive home the point.